Hello everyone. Welcome back to our journey into geometry. Let me ask you something fun to begin with. Have you ever noticed railway tracks? They run in pairs, always parallel, and if one track is parallel to another and that second one is parallel to a third, then what do you expect about the first and the third? Exactly. They too remain parallel. Today, we are going to explore the exact same idea in mathematics, lines parallel to the same line. Let's start by imagining three lines, line L, line M, and line N. Suppose both line M and line N are parallel to line L. Now, we draw a transversal, let's call it line T, cutting all three lines. We get three angles, angle 1 with line L, angle 2 with line M, and angle 3 with line N. Now, because M is parallel to L, corresponding angles are equal. So, angle 1 equals angle 2. Similarly, because N is parallel to L, angle 1 equals angle 3. And if angle 1 equals angle 2 and also equals angle 3, then angle 2 equals angle 3. Which means M is parallel to N. That's the heart of this concept. This leads us to theorem 6.6. It says, if two lines are parallel to the same line, then they are parallel to each other. Symbolically, if line M is parallel to line L and line N is parallel to line L, then line M is parallel to line N. This is nothing but the converse of the corresponding angles axiom. So in simpler words, parallelism is transitive. Just like in real life, if you and your friend both follow the same straight road, then you both are also walking parallel to each other. Now, how do we actually check parallelism using this? The trick is to bring in a transversal. Step 1. Draw a transversal cutting across the lines you want to test. Step 2. Compare pairs of angles, corresponding or alternate interior angles. Step 3. If these angles are equal, then the lines are parallel. In notation, we say angle corresponding equals angle corresponding or angle alternate equals angle alternate implies parallel lines. So, to test parallelism, you don't need to extend lines forever. Just measure or compare their angles with a transversal. That's it. Let's now look at an example from our book. In figure 6.19, we are given that line PQ is parallel to line rupees. We know angle MXQ equals 135 degrees and angle MYR equals 40 degrees. We are asked to find angle XMY. How do we do this? The trick is to add a helping hand, draw another line through point M, let's call it UB, parallel to PQ. This way, we have PQ parallel to UB and PQ parallel to rupees. The construction makes solving much easier. Now let's solve step by step. Since UB is parallel to PQ, interior angles on the same side of transversal XM are supplementary. Which means angle QXM plus angle XMB equals 180 degrees. We already know angle QXM equals 135 degrees. So, 135 degrees plus angle XMB equals 180 degrees. Therefore, angle XMB equals 45 degrees. Let's call this equation number 1. Now, moving ahead. Since UB is parallel to rupees, angle BMY equals angle MYR because alternate angles are equal. We are given angle MYR equals 40 degrees. Therefore, angle BMY also equals 40 degrees. Let's call this equation number 2. Now we combine the two results. From equation 1, angle XMB equals 45 degrees. From equation 2, angle BMY equals 40 degrees. So, angle XMY equals angle XMB plus angle BMY. That is 45 degrees plus 40 degrees, which equals 85 degrees. Therefore, The final answer is angle XMY equals 85 degrees. So let's quickly recap what we've learned. Theorem 6.6 tells us if two lines are parallel to the same line, then they are parallel to each other. We saw that the proof uses corresponding angles. We also learned the angle test method for checking parallelism. And finally, we solved a problem step by step to find angle XMY, which came out to be 85 degrees. Parallelism is like a chain. If line A is parallel to line B and line C is also parallel to line B, then A and C can never intersect. They too must remain parallel. And that's the beauty of geometry. Small observations, like railway tracks or roads, become powerful theorems in mathematics. In the next video, we'll move ahead to explore even more interesting properties of parallel lines. Until then, keep practicing and remember, in geometry, angels are your best friends.